Now question number 12. Question number 12. Two guns situated on the top of a hill of height 10 meters fire one shot, each with the same speed of 5 √3 meter per second at some interval of time. One gun fires horizontally and other fires upwards at an angle of 60 degrees with the horizontal. The shots collide in the air at a point P. Then find the time interval between the firings. First question. Second question. The coordinates of the point. Take the origin of the coordinate system is the foot of the hill, right below the muzzle, and trajectories are in the xy plane. So this is our question. Here I am taking this is x-axis and this is y-axis. Here one hill. What is the height of the hill? 10 meters. From here, two guns, one fired horizontal with u velocity, another one obliquely with the same velocity, which is making an angle of 60 degrees. Then what happened? Its path is parabolic path like this. Again it is coming like this. This also parabolic path. So these two are colliding here. Now this height I am taking as h. This height I am taking as h. So he is asking first one what? First one is asking what is the time interval between two firings? What is the time interval between two firings? Second one what? Coordinate system. Where it is meeting, that coordinate system asking. So first one time interval asking. So this coming time I am taking t1, this coming time I am taking t2. Now what is the time interval? t2 minus t1. This is first question. Next question, this coordinate system, where colliding, that point I am taking p. So this belongs to what? X coordinate. This belongs to what? Y coordinate. What is the P point? Where colliding point? P x comma y. Second thing what? X comma y we are finding. So this is the total information belongs to this question. So here he had given only height of the total height of the hill given, that is 10 meters, and this is 60 degrees given, and velocity also given. What is the velocity? Velocity that is 5 √3 meter per second. What is the velocity? That he had given as u value, both are same, 5 √3 meter per second. And again he had given any acceleration information. Okay, he had not given any acceleration information. So that you take as 10. Acceleration you take as 10. G equals to 10 meter per second square. So this is our question. So in this first what we are doing? When I am projecting this horizontally, it is coming here at x displacement horizontally. So this is called range. Here obliquely projected, and this is also called range. These two ranges are equal at the point, that is x. Again he is asking time intervals. So first I am finding time. So first what I am getting here? X value I am getting. X over I am getting horizontal velocity into time. So x equals to what I am taking here? Horizontal velocity into time. First equation. Similarly, it is coming from year to year. At h, from traveling h down distance, these two are meeting. So here this is how if this is 60 degrees, if this is u, how it is like this is h, right? Here it is making u theta angle. What about this? U cos theta. And what about this? U sin theta. For example, one ball projected from the top of the tower. This H I am taking. One ball projected with u initial velocity from the top of the tower and reaching here. This total time is what? T. So in this case, to find this H, we are having one formula. Body projected from the top of the tower, one formula derived in IP. That is what? S equals to ut plus half at square. This is general formula. Here S means what? For example, moving upward h1 distance. So this is also h1. Moving upward, if we take positive, coming downward negative happens. So what about this? For example, this I am taking h1. Corresponding this thing also h1 happens. Already this h. Now moving upward I am taking positive. Now we take resultant displacement. Moving upward positive taking. So h1. Downward what happens? h1 plus h. If it is upward positive, downward negative happens. So minus half h1 plus h. So totally what I am getting? h1 minus h1 minus h. So s equals to minus h. S equals to minus h. Body moving upward. So that is called acceleration, retardation, minus g. So that value I am taking a equals to minus g. Substitute in this, s equal to minus h. This implies minus h equals to ut minus of gt square, a equal to minus g. This formula I am applying to reach from here to how much time taken? T to time taken. So this I am taking. First to find where the horizontal displacement completed. Horizontal displacement in this belongs to what? Range. Projected like this. Now, what is the range? Here range means this is known in here vertical velocity u sin theta and travel displacement. So this is only displacement s equal to minus h. At that time vertical height comes. So before that horizontal displacement. Horizontal displacement was? So horizontal displacement. Here also vertical initial velocity what? U sin theta. And coming to here. So this concept is for finding h. So that concept we are applying for finding h. Now, what we had completed? Vertically upward, what is the velocity? U. So that you apply h. Again, in the vertically upward, what is the velocity? U sin theta. So here what I am taking?